Okay, hi everyone. My name is Barak. I work for Red Hat, mainly on the oVirt project. And I'll be speaking today about introducing SR-IOV support, native support in oVirt, coming up in oVirt 3.6. I'm a substitute. The original speaker should have been Alona, who was the main developer of the feature, but she couldn't show up, so I'm doing it instead of her. The real credits belong to Alona, who did mostly the engine side, Martin, who did the VFIO part, and Ido Borkan. So it's always a challenge to speak after lunch. I hope you will stay with me all the way. How many actually know oVirt? Okay, nice. How many actually tried oVirt? Good. Well, for those of you who are not aware, oVirt or no, oVirt is an enterprise virtualization DC management. It's a single point of management for the entire needs of the virtual data center. Okay, so what we'll be covering today is these four topics, since most high-level management people not always familiar with the SR-IOV. I'll talk a bit about the SR-IOV basics. I will be covering also a bit oVirt networking basics. It's a big topic, and we can speak about it for hours, but it is necessary to continue on to talk about oVirt implementation for SR-IOV support. And eventually, we'll talk about future improvements. So what is actually SR-IOV? SR-IOV is basically giving a piece of software, a PCI device, the possibility to partition it to several virtual parts, which can be accessible separately on the hypervisor and can be used separately. The purpose, it's actually a several specification introduced by the PCI SIG, which introduced several specifications on this area. PCI SIG is a group of hardware vendors, about 700, I think. They introduced the specification around 2008. And they introduced several specifications regarding that issue. We will be talking about SR-IOV, which is a single root I/O virtualization device. One can think about, when you talk about hardware and virtualization and using directly attached hardware to a virtualization, up to, I think, 7 years ago, it would have been conceived like not the right place, because virtualization in the early days was considered as the next hardware platform, and it is flexible, enables you to manage your data center, move parts around, and so on. So attaching specific hardware from the hypervisor to a virtual machine was conceived as kind of not the right place. But as time evolved, it's not just that the hardware vendors wanted to sell more hardware. It's maybe also related to that. But there were actually specific needs for the virtualization applications to actually enhance performance and do specific things to give servers the ability to near-native performance. So this is one of the reasons, and NFV, of course, which in some use cases will require some near-to-native performance. So this is the reason it came up. So what is it comprised of? It is comprised of, so we have a device, a single root device, a single PCI Express, and it is hooked into a server. And what is there? So there are two parts for the SR-IOV. There is the physical functions that which we see. This is the actual part that when you that enables the administrator to actually manage this device, and it's visible to the host, and it has some additional capabilities that actually expose this feature. And the other parts are the virtual functions. The virtual functions, once the physical function is configured, you can view the virtual functions as a list of devices under the physical device, and you can actually utilize them in a virtualized environment. One thing about the virtual function, it's a lightweight, and it's less configurable than the physical function because all the administration part is done through the physical functions. How does it look like? It's a simple example. You can see IP link. You see at the top level 3 physical devices, and then one of them is the loopback. So 2 physical devices. And at this point, you cannot tell whether it's an SR-IOV device. Once you configure it through the sysfs to have a number of virtual functions. So you see below the lower part, you see 4 virtual functions specified under the physical function.
So you determine how many virtual functions there will be on the physical function?
The question was, do I determine the number of physical functions? Yes, there are 2 aspects for that. One of them is hardware vendor specification. There is a limit. It's not unlimited. You cannot partition it forever. So every piece of hardware supports a different max number, and you can choose as an administrator to configure it as you wish. Yeah. Any other? It's dynamic up to the max number. Yes.
Yeah, so you can increase it, and
yeah.
if you decrease and it's being used, you'll probably fail.
This is an administrative. So how does it look like on a real hypervisor? As you can see, we have 2 virtual machines with virtual functions connected to it on the physical function. On the right side, you can see that it's actually visible in the hypervisor. It can also be utilized as a physical device, and we'll discuss about it a bit later about this possibility. By the way, this by itself can be achieved as is by a different feature called the VFIO. So VFIO actually is the basic mechanism that we implemented SR-IOV on top. So you can actually do it without the SR-IOV support, only with VFIO support. But the limitation is once you hook a virtual function into a virtual machine using VFIO, it's actually pinning the virtual machine to the host, and which kind of misses the point of having it in a data center management environment. But it is still usable in some other. VFIO is a very important feature that enables other things. We introduced the ability to actually have scheduling as a part of the solution. Yeah, later on. So what are the advantages? The advantages. There are obvious advantages like scale, near to native performance in terms of networking. I will focus on the bottom 2 items. First of all is virtualization, means isolation, security. How can we share the same physical device and still enjoy that? So this was a part of the work being done in the kernel, and support for SR-IOV actually takes care of this isolation using IOMMU groups. I will not cover too much the IOMMU group thing, but I will talk later on about some issues with that implementation. And the last part is somewhat, sometimes may be considered less significant, but it is very significant. VMs can share a single physical device, which means, first of all, the hardware is smaller. It means that less power, which is significant, less cooling, and the servers can be small, which is important for vendors. So what are the limitations? Well, the most significant one is live migration, the bottom one. All the rest are, you need to do that manually, and you need to understand exactly what you're doing, and so on. But live migration is the biggest challenge. Live migration, because if you're pinning the hardware, a specific PCI virtual function to a virtual machine, so migration, QEMU, while migrating, takes care of all its memory of the guest, so it migrates it to the other machine. But there is a state in the physical device that cannot be migrated. That's the reason it's a challenge to migrate with virtual functions attached to a virtual machine. So what do I need in order to have use SR-IOV? So here are there are the basic ones, like hardware IOMMU support, which is basically supporting virtualization. Kernel-enabled IOMMU support, which is practically telling the kernel to load the appropriate support for IOMMU groups. SR-IOV-capable hardware. You cannot use SR-IOV if you don't have a card. And the appropriate kernel, we implemented on top of RHEL 7, CentOS 7. And of course, the last part, which is not less significant, is the guest driver. The driver should reside in the guest operating system, because otherwise you will see a PCI device, you will not have hardware, and you will not be able to use it. Questions so far? OK. So till now, we covered the SR-IOV basics. Now we will cover the oVirt networking basics. What is oVirt what is it comprised of? So a logical network. We're not the first one to invent it. Everyone is using some kind of logical networks. The logical networks help us to disassociate the host networking from the guest networking. So in our case, we have several types of logical networks. We have VM and non-VM. We have required, optional, and so on. But what's important here is the VM and non-VM, because we're talking about a VM network till today is built on top of Linux Bridge and OVS if you're using the new trunk support that we introduced in oVirt. So this is about the understanding what is the network. Setup network is about configuring the logical network, which we explained earlier, on the hypervisor. But then again, how can we associate a virtual machine to a logical network? For that, every logical network can have several things that we call VNIC profile. VNIC profile is giving oVirt the ability to later on associate the VNIC device, which belongs to the virtual machine, to the right network, which already exists after we did the setup networks. So basically, all the three first points, like defining the logical network, setting it up on a specific hypervisor, and defining the VNIC profile, is a part of the general setup, and it is done once in a while, very long time. But eventually, when you create a virtual machine and you decide you create the VNIC, then you associate the VNIC with the appropriate VNIC profile, which you defined earlier. And then on execution, this VM is immediately associated to the logical network. So this is a bit of an overview. What is a logical network? So a logical network here is displayed as a part of the cluster, because all the hosts in the cluster in oVirt, all the hosts in the cluster share the same type of networks, same networks exactly. That's enabled us to do migration within the cluster. So we see the hypervisor. It's kind of a logical network across the cluster of the same network. And on top of that, we have virtual machines, and that enables us to migrate between those virtual machines. A little bit more about setup networks, just to make everyone understand what it is. So in this image, what we can see, the setup network takes care of configuring the entire network configuration of the hypervisor. And this is done once in a while. It's not done on a setup when you change things on the cluster or you want to change some network configurations, which are considered quite rare. And this is done, we will see later on, while on the right side you can see the VNIC, which is associated to the VM. And this is actually executed on it is actually applied on the execution of the VM. So on the execution of the VM, we actually attach the VNIC to the right network. Now I have a short demo of this exactly flow just to get a full understanding of what we can see here is we can see a creation of a new network. It has nothing to do with SR-IOV right now. It's simple creation. We create a network. We define which cluster it's optional or required. And then once the network is created, you can see that there is a VNIC profile underneath that is created. And this VNIC profile has a name. You can see it here. It has specifications that you can add, quality of service. Now you go to the host. And once you go to the host, you open this dialog, which is about setting the network. You drag the network you have defined to a specific NIC that you already have on the host, and you have it visible. Now, when you click at this point, it runs setup networks. So this network actually exists on this hypervisor. Now, you go to a virtual machine. You add a VNIC. And when you add the VNIC, you simply define the VNIC profile you would like to use. Now, I chose the VNIC profile that was created earlier, and then all you need to do is simply run the VM, and everything will be connected all together. So you will soon see that the VM is up, and it's running, and it has networks. So far, we've covered SR-IOV basics and oVirt network basics, and now we will approach the main subject, which is oVirt SR-IOV implementation. Okay, the problem. SR-IOV is hardware, and we're talking logical network and hardware. And hardware and logical network doesn't fly, is not connected. Hardware is hardware. So how can we define a logical network on top of a hardware? Because if we can't, then we cannot associate the VNIC to a logical network, which is the standard approach in oVirt. So the solution, and we'll touch it in deep later on, in advance, we define the list of when we identify an SR-IOV device, we define ahead of time the list of networks that can actually live on the physical layer. For example, you hook the server to a switch. The switch, you define a trunk with several VLANs. And then on those, when you hook this port to the SR-IOV device, eventually you can support multiple networks. So we define those set of networks ahead of time. And in addition, so once we did that, we know on execution that this physical device can support this network. In addition, we added to the VNIC profile a specific attribute to say this should be passed through, which means that once it's passed through, then the connection of the entire virtual function to the virtual machine is done on the fly on the VM execution at the same time without having a real logical network on the hypervisor. So how does it look like? So here what we can see that we have two devices which are actually SR-IOV devices. You can see the icon SR-IOV, and we can treat it as a physical device by itself. But once we click the edit for this physical device, we will have additional dialog, which actually on the top level, you can see we can set up the number of virtual functions, which means that at this point, if you click OK and you set the virtual number, change the number of physical functions, the engine will actually ask the VDSM on the host to configure it and persist it accordingly, so it will survive reboots. In addition to that, this is the place where I define exactly the list of networks that this physical layer can support. You can do it in various ways, like you can say I support all networks on this cluster. I can choose specific networks from this cluster to actually say this is only partial subset of the networks in this cluster, or you can use labels as a part. Labels are defined on data center level, but this is not the issue of this presentation. Yes, a question.
Why aren't the cluster defined and the networks defined on the cluster level rather than per host click?
Because it's a physical device.
I understand, but assuming I don't know what is the migration support. I know you mentioned it, but I'm not sure whether it's working or not. You said it's challenging. If you want to support migration, then obviously the same, for all SR-IOV cards, you will need to support the same networks. Otherwise, you won't be able to migrate between one host to the SR.
It has not. You can have several networks, all networks, or part of the networks. We can in future, currently we don't have it, but we can support, like, if you have SR-IOV virtual function available for this virtual machine, allocate. If not, then use a standard network. So I hope.
So another question, is this attachment basically say that this SR-IOV card can support these networks? So once you do that, if these networks are required ones, then the host will be basically operational, right? If there,
good point.
If there is a requirement,
good point.
Don't select.
It's a good point. It's a good point. Yeah. Currently, we support this part as only for optional networks. Any other questions? Okay, so when we edit this SR-IOV device and we choose to change the amount of virtual functions and define all the other association and click OK, at this point, there is a specific API to set everything on VDSM, on the host hypervisor to make it happen. This is actually the VNIC profile, VM interface profile that I talked about. So we have here another checkbox to say this is a pass-through device. And once you set that as a pass-through device, all you need to do when you edit the VNIC, then all you need to do is simply define what profile you're using and define the type of device. And in this case, we added a specific device, a specific type, which is called PCI pass-through. And once you're done, you've done that. I have additional demo here. So what we will see here is we have the VNIC profile we defined earlier. Now we will change it to be a pass-through device. We will simply name it differently, and we will click the pass-through device, and we're just about it. And that's it. Now we go to the host, and on the host, as you saw earlier, we have SR-IOV devices, and we simply edit the host. You see, I did not change here the number of virtual functions, but I can associate the same network I defined earlier as available on this SR-IOV device. And eventually I click OK. And what I will do later on, I will go to the virtual machine, open the VNIC itself. And here, I will change the VNIC profile to be associated with the pass-through profile that I defined. In addition, I defined the type as PCI pass-through, click OK, and then I can simply run this virtual machine, and it comes up anywhere that supports this SR-IOV by hardware. So what are the capabilities? So we actually make sure to configure and persist the virtual functions, manage physical functions, connectivity whitelist, which is the predefined list of networks that we support. Scheduling. Scheduling is the biggest part, so we don't need to worry about scheduling. So what happens when you run a VM with such a profile, it will check all the available hypervisor with this specific configuration and that has available virtual function, and it will allocate this machine on that specific host. Of course, this is a part of the support with SR-IOV. It's setting the VLAN and MAC address, everything on the virtual function itself, so it will enjoy the same connectivity. Good point. It's a part of the future work. I will touch it in one of the last slides.
Another question, so migration one.
Next. Okay, I will answer it later. Okay, what is a mixed mode? Mixed mode is actually having the ability to define on the physical function a standard VM network or whatever network we choose. We can bring out a bridge on that and still enjoy the virtual function and the connectivity through those networks we defined. The additional capability is specifying boot order, but this is standard in QEMU. Okay, future capabilities that we plan. Currently, we don't have hot plug, unplug for PCI pass-through devices. This is supported by KVM and libvirt. Still didn't make it to 3.6. Probably will make it to the next version. This is a necessary building block to enable live migration. There is a talk later on about SR-IOV and live migration. There are several approaches to support that. We actually discussed it with the guys from QEMU and libvirt. The idea is to have two devices, one virt.io device and one virtual function associated into the guest and teamed together. Teaming is it's slightly different, but it's very much equivalent to bonding, slightly different. And then once you want to migrate, you simply hot unplug the virtual function, migrate the VM. The VM still enjoys the virt.io network, and then post the migration, it actually hot plug the virtual function back to the virtual machine, and you have back the support for SR-IOV. This is the general idea. It didn't happen yet. Probably happen in the next version. And opportunistic pass-through VNIC, exactly what you mentioned earlier. It means if I have a virtual function, use it. If I don't, then use the standard bridge. It's still not implemented. Will be implemented probably for next version. What is missing? VF missing functionality means MTU. You need to configure it through the guest, because now the guest control it. And the QoS support. It was introduced in 3.6, and it is still not supported on this on SR-IOV. Okay, hardware issues. It's the last slide, so I know I'm a bit ahead of time. Stole a few minutes from you. Okay, so, well, the great story about the SR-IOV is that it's there. The specification is there, but with our testing and during development cycles, we encountered so many issues on the hardware level support. Like I tried to enumerate some of the things. So some hardware sees all the virtual functions under the same IOMEMU group, which means that you don't have real separation between virtual machines. Some have all kinds of weird errors about bus allocation and so on. So the kernel developers came up with some hacks and tricks to overcome some of the issues, but not all the hardware out there is good enough for the kernel. So only what is supported by the kernel officially and tested, where that tests and supports a specific list of SR-IOV devices, and this is what we support. So it's not that every SR-IOV device is supported. So it's a narrowed list, and there are some hacks to be aware of. Questions? Thank you very much.